Welcome to the Deep Dive. Today we're embarking on a journey into a really provocative stack of sources. We've got articles, research, even patent info, and they challenge some very deeply held beliefs about how we age, why we get sick, and what truly determines our longevity. These documents present a radical, almost quantifiable idea, suggesting that what causes us to age faster or develop diseases, well, it might not be what you think at all. So our mission for you today is to unpack this compelling concept of invisible toxins. We'll explore how it connects to everything from where you live to a groundbreaking new technology, and hopefully leave you with a completely fresh perspective on human health. Okay, let's dive deep into this.
It's a fascinating premise, definitely. One that really invites us to look at human health through, well, an entirely new lens. Moving beyond what we've traditionally accepted, if we connect this to the bigger picture, the material we've reviewed offers a remarkably coherent model, almost a kind of unified theory, explaining why some people age faster or develop diseases earlier than others, and seemingly irrespective of their genetic background. It's a very bold claim, and the sources lay out a pretty detailed argument for it.
Yeah, for decades, if you talk about aging or disease, the conversation always circled back to genetics, right? Or diet, or lifestyle. It felt like settled science, almost. A checklist of what we should or shouldn't be doing. But these sources really challenge that. They suggest that while those factors are obviously important,
undeniably important, yes,
they might not tell the whole story. In fact, they argue these traditional explanations often fall short, especially when trying to predict or measure why certain populations or individuals age differently. So what's the missing piece, according to this material?
That's precisely it. What's truly fascinating here is how the traditional scientific community, despite, incredible advances, has struggled to create a truly predictable, measurable, and importantly, reversible human model for health and aging based solely on genes or lifestyle. And that raises a really important question. What if there's a crucial, maybe overarching variable that we've largely overlooked? Our sources introduce this as the human toxin accumulation saturation point, or TSP.
TSP,
yeah, TSP. It's presented as the central unifying key, the key to understanding why some populations age faster or are more prone to certain illnesses, and why those differences aren't just, random chance.
Okay, so if this toxin saturation point is the ultimate driver,
Yeah.
the big question is, how are these toxins actually getting into us? Like you said, we're not consciously drinking poison, right? So how does it happen? Our sources really break down the stealthy ways these things infiltrate our bodies. They identify four main pathways.
It's an excellent point, because often we imagine toxins as something, overtly dangerous, like a skull and crossbones label. But the sources paint a picture of constant low-level exposure, which raises an important question for all of us, really. Are you truly aware of all the ways your body is exposed day in and day out? The material identifies four main routes. First, and this is cited as the most significant source, airborne toxins.
The air we breathe.
Exactly. We're talking about things like acids, alkalis, and these incredibly tiny ultrafine particles, specifically PM 0.1 and below. Just to give you a sense of scale, a human hair is maybe 50 to 70 micrometers thick. These PM 0.1 particles, they're just 0.1 micrometers, tiny.
Wow, much smaller than dust or pollen then.
Far smaller. They come from industrial waste, car exhaust, everyday plasticizers, perfumes, various kinds of smoke. And because they're so minuscule, these toxins just bypass our body's natural filters, like the hairs in our nose. They can, as the sources put it, directly enter the bloodstream via the alveoli.
Little air sacs in the lungs.
Right, the ones doing the oxygen exchange. So these toxins become a primary systemic threat. They can travel throughout your entire body.
So even just walking down a busy street.
Yeah.
Or wearing certain fragrances that could be actively contributing to this toxin burden. That's pretty sobering.
It is, absolutely. Then second, we have food and water toxins. This category includes things like pesticides, chemical fertilizers from agriculture, heavy metal residues like lead, cadmium, mercury that can sometimes be found in our food supply, plus common water contaminants like chlorine, fluoride, even microbial toxins.
Things we might not even taste or notice.
Often no. And unlike airborne particles that can quickly enter the bloodstream, these toxins tend to, according to the sources, long-term accumulate in the liver, kidneys, and intestines. This leads to sustained metabolic stress and gradual deposition within those vital organs. Think of it like a slow, steady drip of inputs that your body constantly has to filter and process.
Okay. And often, we don't even realize we're ingesting them. What's the third pathway?
Third, and this one's often underestimated, is dermal absorption. through the skin.
Through the skin. Okay.
Yeah. This refers to chemicals in cosmetics, cleaning agents, hair dyes, sunscreens, even toxic molecules leaching from everyday items like some metal jewelry or plastic products. These chemicals enter the bloodstream through pores and sweat glands in your skin. And because they're absorbed gradually, they can build up kind of unnoticed, potentially lingering in your system for a long time. Imagine a slow, continuous infusion directly into your body, but without any immediate alarm bells going off.
That's a stark reminder, isn't it? Everything we put on our bodies, not just in them. Okay, what about the last category?
Finally, there are drugs and modern chemicals. So the long-term use of various medicines, while necessary and therapeutic, can sometimes leave behind what the sources call secondary toxins after they're metabolized by the body. And then there are volatile organic compounds, VOCs. These are gases released from everyday stuff.
Like new furniture, paint.
Exactly. New furniture, fresh paint, building materials, plastics, that new car smell, or the scent of a freshly painted room, often a cocktail of VOCs. So without really effective expulsion mechanisms, these diverse toxins from all four pathways, they tend to settle in cellular gaps and deep organ tissues. The accumulation process itself is described as a three-step journey, almost like a silent invasion. First, toxins enter the blood from any of those four pathways. Think of your bloodstream as this huge highway network.
Right.
From there, they distribute throughout the body, traveling via the blood to different organs and tissues. And then, the critical step, they deposit and fix. This means they literally bind with your cells or get stuck in your tissues, steadily building up their concentration until that saturation point, the TSP, is eventually exceeded. It's a slow, steady burdening of your internal systems, kind of like a sponge slowly soaking up water until it just can't hold anymore.
Now, if you're like me, you've probably always thought, our genes hold the ultimate key to how fast we age, right?
Mm-hmm.
We talk about genetic predispositions for everything from heart disease to longevity. It seems baked in. But our sources are about to kind of flip that idea on its head in a really provocative way.
Mm-hmm.
They claim that differences in how quickly people age or get sick aren't fundamentally about genetic superiority or inferiority, not between different human populations. Instead, it's about something far more external, far more environmental.
Precisely. This really challenges that long-held notion of inherent genetic predispositions just dictating our health destiny. The material proposes that where you live and the specific toxins you're exposed to there play a far more significant role, maybe the most significant role. It suggests that these differences in how quickly people age or get sick are actually due to varying toxin input speeds.
Toxin input speeds. Okay.
Yeah, speeds determined by differing air environments, chemical exposure concentrations, and, importantly, the body's ability to clear them.
So it's not our DNA, but our daily environment that's the primary dial tuner, so to speak. Can you give us some concrete examples from the sources?
Yeah, the sources provide several compelling regional examples to illustrate this point. They're careful not to generalize too broadly, but they highlight patterns. They suggest that in some European populations, for instance, the combination of factors like high perfume use, relatively higher alcohol consumption, the practice of keeping windows closed in winter, for warmth and energy efficiency, and potentially higher indoor VOCs from certain furnishings. These things collectively are linked to elevated rates of certain cancers, particularly breast and prostate. The idea is that these factors together contribute to a higher overall toxin burden for some groups there.
Okay, so it's a specific mix of exposures.
Exactly. Then, the material points to patterns observed in some African-descendant communities, particularly those living in urban areas. Here, exposure to significant air pollution, common household cleaning agents, maybe higher levels of car exhaust. These exposures appear linked to an earlier onset of certain chronic diseases, including higher risks of asthma and kidney disease in those specific settings. It's presented as a direct connection to that urban environment's particular toxin profile.
So again, it's about the unique cocktail of exposures in those specific environments, not some inherent biological difference tied to ancestry. That makes a lot of sense when you frame it that way.
Exactly. And conversely, the sources note that some East Asian populations, often characterized by cultural tendencies, maybe for less fragrance use, more natural, often traditionally plant-based diets, and perhaps a stronger cultural emphasis on indoor ventilation. Well, these populations are noted for exhibiting, on average, slower signs of aging and delayed skin aging. Again, the sources stress this isn't about cultural superiority, it's about a lifestyle that, maybe by happenstance, results in a lower overall toxin input.
Interesting contrast.
And finally, they mention some areas of the Middle East and India. Here, exposure to factors like intense spice smoke during cooking, formaldehyde from certain commonly used building materials, and maybe persistent frying fumes, these are associated with chronic respiratory irritation and an aging process that seems particularly concentrated in the lungs and liver in those contexts.
Right.
So the takeaway from all these examples is really clear. The sources contend it's not fundamentally a cultural issue nor a racial one. It's fundamentally a total toxin input issue. Your specific environment, the air you breathe, the products you use, the food you eat, all directly influence the speed at which toxins accumulate in your body. It's a really compelling argument for environmental factors being paramount in aging.
This idea of different toxin input speeds based on environment is pretty revolutionary on its own. But the sources take it even further. They suggest this isn't just a contributing factor to aging, but maybe the fundamental driver. So what does this truly mean for how we understand the very process of getting older? Our sources propose a bold, quantifiable idea here, tying it directly to that internal accumulation.
Indeed. The author, Fuqi Wu, posits a truly radical concept. They state that the degree of human aging is completely equivalent to the internal toxin accumulation saturation ratio. This basically means aging isn't just a chronological process, measured by candles on a cake. It's presented as a measurable internal accumulation of toxins, a direct correlation.
Can you elaborate a bit on what saturation ratio means in this context? It sounds very scientific, but what's the practical implication for, how we feel or look?
Sure. Imagine your body systems, your liver, kidneys, cellular detox pathways, they're constantly working to process everything that comes in, right? They have a certain natural capacity, a limit to how much they can handle efficiently before becoming stressed or overwhelmed. The toxin saturation point, or TSP, isn't necessarily like an overflowing cup that instantly causes disaster. It's more like a measurable percentage of that capacity being filled up or burdened by these accumulated toxins. It's about how much of your body's processing power is being consumed just dealing with these foreign substances.
Okay, so it's about how taxed the system is.
Exactly. So to use the sources example, if one group's internal toxin burden reaches, let's say, 60% of their body's processing capacity at age 40, they might start to manifest chronic conditions. Things like hypertension, diabetes might start appearing. But another group, perhaps living in a cleaner environment, whose internal burden only reaches that same 60% saturation at age 60. Well, they would consequently appear and feel significantly younger overall for much longer.
Makes sense.
This perspective really suggests that those surface lifespan differences we observe between groups, the visible and felt differences in health and vitality, are not primarily about DNA, but about the speed at which that internal toxin saturation point is reached. The TSP, in essence, becomes this critical boundary line, the point where the body transitions from just aging to developing actual diagnosable disease. It's the moment your systems are so taxed, they start to visibly, measurably break down.
That's a powerful reframing of how we think about disease onset, definitely. Okay, so given this profound insight into how pervasive these invisible toxins are, our sources also introduce a potential game changer, right? A category of technology designed to drastically reduce our toxin input, specifically from that most significant source, the air we breathe.
Yes, exactly. It highlights a practical application of this whole toxin saturation point model. The sources basically say, look, if air is the most significant pathway, then controlling that input is paramount. They introduce the concept of advanced air purification technologies, and they specifically highlight one example, the Air 6-Free Maze Purifier.
Air 6-Free Maze Purifier.
Hey.
Yeah. This is presented as a pretty sophisticated device, promising an environment that achieves 6 specific goals: dust-free, germ-free, toxin-free, smoke-free, odor-free, and heavy metal-free. Its core purpose is to provide ultra-clean air, fundamentally altering that primary toxin input channel we talked about.
So it's definitely not just a fancy fan with a standard HEPA filter then. Sounds like there's a much more specific multi-stage process at play to hit all 6 of those frees.
Exactly. The material describes it as utilizing an 8-second air 6-free maze purification principle. That implies a rapid and thorough process. It's designed to tackle particles far beyond what conventional filters can typically manage. Let's break it down. In step 1, there's initial negative ion charging and HEPA prefiltration.
Okay, so it's actively charging particles first. Right. It's not just passive filtering. The HEPA filter itself, that stands for high-efficiency particulate air, is a known standard, good for trapping larger stuff like dust, pollen, some microplastics, even some VOCs. But that's just the beginning here. Step 2 involves secondary ionization. This takes the concept further. It uses more negative ions not just to charge particles, but to actively neutralize pathogens like bacteria and viruses, and even break down chemical toxins at a molecular level.
Wow, so it's essentially zapping harmful particles and breaking them apart before they even get to the main purification stage.
That seems to be the idea presented, yes.
Yeah.
Then, in step 3, the air enters what's called the electrostatic maze box. This is where those charged particles are drawn into a highly effective electrostatic field. It permanently captures all those ultrafine pollutants, even the tiny PM 0.1 particles we discussed earlier. They get stuck to charged surfaces inside this box.
Like flypaper for nanoparticles.
Sort of, yeah. Then step 4 introduces a unique maze effect. So instead of a straight path, the air is forced through this complex series of sharp turns and twists within the maze structure. This physical manipulation, the sharp turns, causes any remaining airborne nanoparticles to literally crash into the maze walls and become physically trapped. It ensures almost nothing gets through.
Clever, using physics too.
Right. And finally, step 5 ensures that only ultra-clean, toxin-free air is released, aiming to fulfill all 6 of those free claims by the time the air reaches your breathing space. It's presented as a very multi-layered, comprehensive approach to creating a truly purified air environment.
That is a comprehensive process. Okay, but the big question. If we can significantly reduce the amount of toxins we breathe in, say, through a system like this, what's the tangible impact on our personal toxin saturation point? And ultimately our lifespan, according to these sources? What are the implications for us listening right now?
Yeah, this brings us squarely back to the core premise and really the promise of this model. The sources assert that by spending just 12 hours a day in toxin-free air, achieved through such technology, your total toxin input can drop by over 90%.
90%. Just from cleaning the air for half the day.
That's the claim. A dramatic reduction in the overall toxin burden, focusing on that primary airborne pathway. And consequently, based on their TSP model, it's claimed your aging speed could potentially be halved. And your toxin saturation point could be delayed by 10 to 20 years, which would naturally extend your healthy lifespan. Now, these are obviously bold claims, very significant numbers, but they're presented as direct consequences of accepting the TSP model and implementing solutions like this.
Having your aging speed, delaying your TSP by a decade or even 2, those are absolutely staggering numbers. And the sources also describe this kind of technology in a pretty profound way, don't they? Something about it being a human equity system. What does that mean?
They do, and that's one of the truly fascinating aspects here, how the concept positions this technology. It's described explicitly as a human equity system. Why? Because it's presented as being cross-race, cross-culture, cross-belief, suggesting its potential benefits transcend all those traditional backgrounds or divisions. The core message seems to be, it doesn't matter your nationality, your genetic makeup, your philosophical leanings. The only question it asks is essentially whether you are willing to believe the toxin model is true and then act upon it.
Ah, okay.
Yeah.
So it puts the power or the potential benefit in the hands of the individual based on belief and action, regardless of who they are.
Exactly. In that sense, it offers a potentially universal path to longevity, independent of those traditional divides. It puts everyone on a more level playing field where the choice to actively mitigate toxin exposure becomes the primary determinant of health outcomes, according to this model.
So wrapping this all up, what does this mean for you, our listener? Our deep dive into these sources paints a vivid, maybe somewhat unsettling picture. The core message is, what truly determines how fast you age isn't primarily your nationality, your genes, or even just your diet, but fundamentally how many invisible toxins you inhale and absorb daily. It's a really complete shift in perspective.
It absolutely is. This perspective fundamentally shifts how we might view health, disease, and longevity. It challenges us to look beyond conventional wisdom. And the material culminates in a stark yet remarkably insightful summary from the author, one that truly brings home the urgency of their message, they say. From the TSP perspective, all humanity is divided into 2 kinds of people, those accelerating aging and those preventing toxin accumulation.
Wow. Accelerating or preventing, that's quite the dichotomy.
It is, and in a very dramatic final thought, the author states that basically outside of accidents, all humans are slowly poisoned to death by toxins. Now, that's a stark way to put it, certainly, but it underscores this idea of a constant, often unnoticed environmental battle our bodies are fighting every single day.
All humans are slowly poisoned to death by toxins. Okay, if our sources are correct, even partially, and if this really is a major underlying mechanism of aging and disease, then that raises a profound question for all of us listening. What small, yet maybe impactful steps can you take today to shift, even slightly, from accelerating aging towards actively preventing toxin accumulation. Perhaps it starts just by becoming more aware of those invisible threats potentially present in your daily environment. That's definitely a thought to mull over until our next deep dive.